Prove algebraically that the sum of the following is always a square number. Well, sum means to add. So my first step is going to add up my two expressions. So I've got a half n and in single brackets n plus 1. We know sum means to add, so plus a half. And then we've got double brackets of n plus 1 multiplied by n plus 2. Well, first of all, expanding out my single bracket, whatever's outside, I multiply by each term directly inside. Well, a half n times n will give us a half n squared. And a half n times positive 1 will give us plus a half n. Leave this half outside for now. Expanding my double brackets, n times n will give us n squared. N times positive 2 will give us plus 2n. 1 times n will give us plus 1n, or just plus n. And 1 times 2 will give us plus 2. Again, leaving our half n squared and plus half n alone for now. Leaving the half again outside. Simplifying, I collect in like terms inside. I've got n squared, no other term ending in n squared, so write that down. I've got 2n plus n, they're like terms, so they both end in single n. If there's no number in front of a letter, the number is 1. So 2n and 1n will simplify to give us plus 3n. And I've still got plus 2. Once again, leaving my half n squared plus half n alone. Expanding now out my brackets, I know a half times n squared will give us a half n squared. A half times positive 3n will give us plus 3 over 2n. And a half times 2 will give us plus 1. Collecting like terms, or like terms have the same combination letters, including powers. So here I've got half n squared plus a half n squared. They're like terms, they both end in n squared. Well, a half plus a half is 1. So therefore that simplifies to give us n squared. Collecting my single letters of n. Here I've got a half n plus 3 over 2n. They're like terms, they both end in n. Well, a half plus 3 over 2, that will simplify to give us to plus 2 lots of n. And I've still got my number term, in this case, plus 1. Returning to our question, we were asked to prove algebraically that the sum of our two expressions is always a square number. Well, if we think about it, a square number is going to be the form something to the power 2. What is special about n squared plus 2n plus 1? Well, I can factorise that. As I've got 3 terms, and it will factorise into what we call double brackets. As it starts n squared, each bracket will start with a single letter of n. I need to find two numbers that multiply to give us the number term, in this case, positive 1. And the same two numbers must still add to give us the number in front of our single letter, which in this case is positive 2. The only two numbers that multiply together to give us positive 1 and still add together to give us plus 2, in this case, is going to be plus 1 and plus 1, because 1 times 1 is 1, and 1 and 1 gives us 2. What is special about n plus 1 times n plus 1? Well, they're exactly the same, so I can rewrite that as being n plus 1 in brackets squared, which proves that it'll always be a square number.